Hello there, Mr. Sutton here, bringing you the Algebra 2 1-1 Part 1 homework solutions on parent functions and transformations. In this one, we're going to be dealing exclusively with the parent functions and translations. For this first problem, they want us to identify the function family shown here in the graph, and then write the domain and the range. So for the family, we can see from this V shape here, and also, they spelled out the function. It has the absolute value in it. This is definitely an absolute value function. So now the domain of that, of all absolute values, is going to be all real numbers. You can plug in any x value you want, and you see the graph going left and right forever, so all reals for the domain. For the range, absolute value, the parent function, has a range of y greater than or equal to 0. You can't get negative values back from absolute value unless the absolute value has been shifted down like this one has. So in that case, you can think of this absolute value part of it as being, no lower than 0. So we could say f of x is going to be greater than or equal to whatever 2 times 0 minus 8 is. I like to use 0 as a stand-in for the absolute value minimum. And then 2 times 0 is just 0, so that leaves us with just greater than or equal to negative 8, which if you look at the graph, clearly we're above negative 8 and not going below it. For this problem, we're trying to identify the function family and the domain and the range of what's shown here. So this is a slanted line, and it also has a formula with an x to the first power as the highest exponent in there. So this is definitely part of the linear function family. For the domain, we're going left and right forever, and all linear functions have a domain of all real numbers. And then for the range, we're also going down and up forever, so all reals for the range. On this one, they're trying to get us to identify this function family along with its domain and range. So the horizontal line and the fact that the function just equals a constant tells us that this is the constant function family. For the domain, we can plug in any x value we want, go left and right forever. So that's going to be all real numbers for a domain. For the range, there's only one y value that we can get back, and that is 3. So we just have y equals 3 for the range. On this problem, they want us to identify the function family of the g of x function and also write the domain and the range. Since we have an absolute value function in there, this is the absolute value function family. For the domain, all absolute value functions have a domain of all real numbers. You can plug in any x you want and it'll still give you a value back. For the range, absolute value, this absolute value part of the function has to be 0 or greater than or equal to 0. But we also have this negative 1 that's influencing what the final output can be. So I'm going to start by writing g of x is greater than or equal to 0 minus 1. I'll use 0 instead of the absolute value. But then, because we have this minus 1, g of x actually is going to be greater than or equal to negative 1. We can get negative 1 and anything above that back. On this problem, we're trying to describe and graph the transformation f of x equals x minus 6. So let's start with the parent function. This is linear. This is just going to be f of x equals x for the parent function, which means the parent table is just going to have the points 0, 0, and 1, 1. Now, in terms of the transformation, since we're subtracting 6, we can think of this as outside the function. So this is going to be like having going down 6. You also could think of this as being kind of inside a function and think of it as like right 6. Either way, down 6 or right 6, you're going to end up with the same looking type of graph. So in terms of rules, the x is not changing at all if we're thinking about this vertically. We can just call that x. For the y rule, we can call this y minus 6. So the x's are still 0 and 1. And for the y's, we're now going to have negative 6, and 1 minus 6 is negative 5. Graphing those out, we have 0, negative 6 right there, and 1, negative 5. And we can draw the line through those. Now you could also graph this just in y equals mx plus b type of reasoning. We have a slope intercept of negative 6 and a slope of up 1 over 1, which is what this graph has. For this problem, we're trying to graph and describe the transformation for 4 plus absolute value of x. Well, this is absolute value, so using the absolute value parent function is a good way to start. and that has the 3 points negative 1, 1, 0, 0, and 1, 1. Now, in terms of transformations, this is really like having absolute value of x plus 4. It's the same thing. So this is going to be, since it's outside and we're adding 4, this is going to be a vertical shift of up 4. So we're translating up 4. That means the x rule is not changing at all. We're just going to call that x still. For the y rule, though, we're going to have to do y plus 4. So for the x's, I still have negative 1, 0, and 1, just like the original. For the y's, I now have 1 plus 4, or 5, and then 0 plus 4 is 4, and we still have 1 plus 4 being 5. Graphing those out, we have negative 1, 5 right there, 0, 4, and 1 comma 5 is right up here, and then draw the absolute value v through those. For this problem, they want us to graph this function and describe the transformation going on. So the parent function for this one, since I have absolute value, I'm going to do the absolute value parent table, which has negative 1, 1, 0, 0, and 1, 1, just a little v at the origin here. Now, what's actually happening with this transformation? Well, this minus 3 inside is going to give us a shift of right 3. Inside changes are left, right, and they're opposite of what you expect. And then this minus 2 outside, that's an up-down change since it's outside. And that's going to give us a shift in the direction we expect, which is down. So we have right 3, down 2. So let's come up with a new table for f of x here. For the x values, if we're shifting right 3, that means we have x plus 3 for the new rule. And for y, down 2 means y minus 2. So for the x's, adding 3 to all of the originals, we have negative 1 plus 3 is 2, 0 plus 3 is 3, and 1 plus 3 is 4. For the new y values, 1 minus 2 is negative 1, 0 minus 2 is negative 2, and this is negative 1 again because it's the same number going in. Graphing those out, we have 2 comma negative 1, 3 comma negative 2, and 4 comma negative 1. Gives us a little v shape that has been shifted.